Okay, I'm Emmett Wilson. I work for Asynchrony Labs based out of St. Louis, Missouri, and I'm on Twitter at Mathematical Funk. Welcome to Android Zombies, How to Not Get Bit. So, today we're going to cover a couple things. What exactly is a zombie Android app? How are they created? What happens when we are bit by an Android zombie? And how do we easily test our apps to make sure that our users have good experiences and we don't have to deal with Android zombies? And then finally, we'll cover a grab bag of resolution strategies for how to gracefully recover when it inevitably happens. So an Android zombie is when Android kills your process. Typically this happens when your process is backgrounded or your application crashes and then your application is recreated. The zombie metaphor is really good for this because the Android system, when you tap via the launcher icon or via recents after your application has been terminated by Android, it brings you right back to the original screen that you were on. So you come back deep into your task stack. If you're 4 or 5 activities deep, you're going to come back onto that 5th activity, and it's going to expect that you have some sort of a backstack, and it's going to expect whatever global data and models that you had around in memory to be there. And we've talked a lot about Android architecture the last couple months, last couple of years, and there's kind of some basics from the Android fundamentals that we learned in the very beginning that when we start moving to other architectures we may forget about. And so we're going to touch on those as well. All right, so Android process death and recreation is not configuration change. For those of you that are familiar with configuration change, this is things like screen rotation, plugging in or disconnecting a hardware keyboard, walking into or out of a Bluetooth keyboard connection, walking into or out of a Android Auto connection, or changing the font size for accessibility reasons. Configuration change is similar in that the UI layer is torn down and recreated, but you still have the backing application with all of the data. So there are patterns that are really good for handling configuration change that are also really good for handling process death and recreation. But there's also patterns that are really bad for process death and recreation that give us a false sense of security when we have configuration change. This is also not the don't keep activities. Don't keep activities is similar because we have things being torn down and recreated when they're in the background, but it's only the background activities in our task stack. It's also not swiping the app away from recents because that kills our application, and when we come back in, we're not expecting a build-up task stack. We're not expecting to come back into the most recent state we were in, and it's not backing entirely out of the application because, again, you don't have that deep task stack. All right, so how are Android zombies created? The 2 ways that I've observed are you background your app, and then the user goes and does something else, and for whatever reason, whether it just be time elapsing or it be opening another application, Android decides to destroy your application, but it still keeps it in your recent tasks. And whenever you go to recent or you go to your launcher icon, it brings you right back, and your application experiences a recreation. Another one that I first saw this with was when your application crashes. So if you have a deep task stack, you're 5 or 6 activities deep, when your application crashes, it'll tear down the current activity, and then whatever the next activity in your task stack was, that activity will be recreated. So what happens when we follow the not most robust patterns and we have a zombie application? Sometimes we'll come back to the application and it just immediately crashes because it's expecting something to be there, and you get a null pointer, and this happens either from recents or your launcher icon. Sometimes you'll land on a page and you no longer have memory models, and you're just presenting junk data to the user. It's not there, it looks like a vacuous screen. You'll see App Store reviews like I opened it up and it just totally busted. Sometimes you'll see a crash and a crash and a crash again. So this is kind of, when I open it up and it crashes, it goes back to the next activity in the stack. If that's expecting something to be there, you'll get a second null pointer. And then it keeps going all the way back down, and that's when you start seeing that dialogue like, so-and-so application keeps crashing, do you want to force close it forever? Sometimes you will come in, and while you won't crash immediately, the user tries to do some user interaction. They click a button, they try to swipe to a tab, and the data for that's not populated. And so they come in and they crash as soon as they start trying to do something. And then the worst of all is if they don't crash when they hit one of these buttons, maybe you save some data to a database, and you're saving bad data to the database, and then you can't recover until they end up deleting their database because it's junk data that you don't know how to handle. All right, so things to look out for to know danger nearby is global memory data. So this is your static singletons. This is your member variables that you're storing in your application instance. This is also your injectable memory models that you're doing from Dagger. So just because Dagger 2 or Dagger, you're injecting things like your repositories and your presenters, and those are really great because you could have it persist behind the activity and survive configuration change and rotation. But when your application is killed, they're not there anymore and they're recreated. So that those member variables that you're expecting and that state you're expecting isn't there. So just because you're not storing in the application class doesn't mean that it's not globally scoped and being torn down. Another thing is retained fragments. Whenever you read the Android documentation, they mention that retained fragments for persisting views is an anti-pattern, and they never elaborate. But people suggest using them for saving state or persisting across configuration change, especially on Stack Overflow. So when you see these, you have to be cognizant that a retained fragment is great because it is going to survive configuration change and reattach to the new activity. But once again, your retained fragments and your fragment manager and your loader manager, those are all torn down when your process is torn down. I mentioned static member variables and activities and fragments. This is similar, but it's more of a configuration change issue than a process death issue. But it's just another thing because you get similar crashes across configuration change if you don't handle that as well. And then kind of the crux underlying all of this is activities and fragments that are relying on this state to be there. So the real danger is when you have an activity that's 4 activities high on the task stack and it's expecting some previous state. It's like maybe you're on a checkout screen and you're saying, I can't check out unless I have a cart. Well, if it's expecting a cart to be there in memory and it's not relying on it being in your database or saved to disk, then when you come back and you don't have that cart in memory anymore, then you're going to have crashes. All right, so now that we covered kind of what an Android zombie is, how do we test our apps to make sure this doesn't happen? So the first one, and this is one that our users probably experience, is to background our app and open another resource-intensive app. So these are your things like Pokemon Go and Netflix, Clash of Clans, 100 Chrome tabs. They're pretty resource-intensive. And I don't fault them for being resource-intensive because honestly, if I'm playing a game, I want it to be the most engaging, enriching experience that I can play. So I expect them to be using lots of resources, and hopefully they're tearing down applications in the background because I'm getting very good content. So the only real pro of this is it's the most realistic. This is what your users are seeing in the wild. The cons are it's non-deterministic. So you have no hook into knowing when this happens and when it doesn't happen. So when you're trying to recreate this to test how your application responds, you don't know for sure that your application has been killed. Especially now that memory on devices is going up, and both the Android community and the operating system are getting much better at managing resources. So it's less likely to happen, but it still happens frequently, just not in that quick zone where you're sitting there on your Pixel and testing and expecting feedback in the next 5 minutes. So this is actually the way that I discovered this. I call it the Samsung font style trick. And so a little backstory is I was working on an app, and we had some configuration change crashes, and so we were being diligent and going through trying to fix every configuration change crash that we had. And when we were testing, we were changing the font size, and on Samsung we noticed there was a font style that we could change. And when we changed that, it would still crash, and we didn't understand because we weren't getting the configuration change event. Well, as we started looking into analytics, we realized that our process was dying. And we're like, this is a thing? Who knew? And so when I was looking for information, I couldn't find information about this. It's mentioned vaguely some places on the internet, and then conversation tends to go dark afterwards. So I put together a video. So in this video, I have a sample app that I made called Taco Tuesday, and I'm wanting to test it for process death and how it handles it. So I open my app, do some interactions. I want to see what happens when I'm on the third tab. And then I go to settings. And then in display on Samsung devices, you have a font settings page, and in there you have things like Choco Cookie. And so maybe I want to apply this to my entire application. So you notice when I did that, there was a flash on the screen. That was the settings application being torn down. Now when I come back to my app, you also notice there's a flash. And that's because the application was torn down. It's having to recreate the application, and then it's having to recreate all of the activities. So that's pretty quick feedback. All right, so the pros of this is we now have a deterministic way we could cause process death for applications. So we get kind of quick feedback, and we could test it, but we have to use Samsung devices, so that's a con. Because maybe I don't have a Samsung device available. Also, you have to deal with the funky fonts. Like, sometimes you forget to change it back, and you just have to look at Choco Cookie. And that's not very visually appealing to me. So there's a little bit better we could do. There's actually something built into developer options that we can use to do this. So I put together a demo of testing my application using developer options. So here, I open up my app, Taco Tuesday, and then I background it after doing some user interactions. And I go to my settings application and go down to developer options. And then we're going to scroll for a while. So just hang tight. It's down there somewhere. Still scrolling. Still scrolling. All right, there we go. Limit background processes. So if we turn that to the no background processes, then we can leave, and our application was in the background, so the process was terminated. And when we come back to our app, it's in the foreground again. Now, I added to the video and scrolled down again because you always want to make sure you turn this off. And so you want to put it back to the standard limit. Now, we'll talk about that in a moment. The pros of this is it's deterministic. It's going to shut down every time, so we can reliably test how our app responds to process death. And it works on all devices, so now we could test on emulators, we could test on our Pixel, and we're not beholden to having a Samsung device on hand. The con is I accidentally left it on, and I don't know what my app's doing. So I've actually experienced this where we had a phone where we were testing this, we left it on overnight, left for the weekend, came back, and things just weren't behaving right, and we thought we had a bug. We were trying to investigate enough to write up a user story, and it turned out we had that developer option still turned on, and it's kind of buried down there, so it's not the first thing you go to. Another con is it's going to destroy all background processes. So if you're wanting to test your integration with another application, or you're wanting to test deep links or push notifications, it could cause issues with those. So for my team, I wrote a quick utility to targetedly terminate my application. So I put this up on GitHub, and it's probably unrealistically simple. So there's probably lots of use cases it doesn't use, but it works well for mine. And it's on Google Play, but I encourage you to download it or fork it on GitHub. And so here's the demo of me testing my app using App Terminator. So I open my test app, Taco Tuesday, do some user interactions, open App Terminator. It shows only your debuggable applications, so you could quickly find them. And then you click on it, and it terminates it. And when you go back, you're experiencing recovery from process death. So it's a much tighter feedback loop. And kind of the big takeaway for this is it works on all devices, it's deterministic, but it's only killing your app. so you make sure you're not dealing with the other system maps, and you could better test how you're handling push notifications and deep links. And I feel it's the fastest feedback of the methods. The big con is it's most likely made by an evil developer. All right, so now we know what Android process death is and how it creates zombie applications and what the dangers are. We know how we can test our app. Now let's talk about how we can offer our users a seamless reentry experience when this happens. So the first one is just recovering by persisting all of our models and data that we're expecting to populate the UI onto the disk. So there's a couple ways we could do this. The first one is to go back to Android 101 and leverage intents, save instant state, and bundles. So if we make sure that we're passing the data that's going to populate our UI for an activity or a fragment into an intent or a bundle, and then properly leveraging save instant state to save our user interactions, then Android persists the data for us. We're not relying on static singletons or global memory models to persist the data across configuration change. So that's really good. But there's some drawdowns too. One of them is you have to write all of your parsable code. And yeah, there's libraries like AutoValue and Parseler, but there's still some amount of maintenance to writing parsable code. There's also a limit on how much data you could store. So with the advent of NuGet, transaction too large exceptions started happening. And they've been happening for the previous versions, but they used to silently happen. And now they'll crash your app. So if you have large data or large lists of data or lots of images, there's only a finite amount of space that they reserve for you that actually goes down as the API levels increase for saving instant state. And then the final con is if you're doing network calls and your app is backgrounded, you get save instant state before the network call completes. So if for whatever reason your user is on a 3G network and I'm tired of waiting for my network call to respond, this app is behaving slowly, and they background your app, and then your network response finally happens. When they come back, they're not going to get it because it's not going to be available for save instant state. So the second option is instead of saving all of our data, we're going to still use intents and bundles, but we're only going to save enough keys and values to load from our server what we're interested in. So here maybe you have your user ID, maybe you have some unique ID that you could load a product or a destination. And then when the user comes in, you pull those out of your intent or save instant state and then load what you need to from the network. Again, Android is persisting the data for you, which is awesome. And it further mitigates the risk of transaction too large exceptions because you're not using such a large data set. But you might not get the best user experience when you have a slow network connection. So the next Android 101 option is to leverage SQLite. This is probably your most robust option because you get full database. You can do network caching. You can leverage SD card storage. You get upgrade pathways to persist data across installs. But sometimes when you're doing a greenfield app or you're trying to iterate quickly, you don't know what your final models are going to look like. You don't know what you're going to need. And there's a lot of overhead and boilerplate that you have to deal with. So hopefully with the advent of Room and things like Realm and some of the other ORM libraries, this becomes easier and less prohibitive. Another con, which is also one of the pros, is upgrades are hard. You have to manually write the code. You have to test all of the different upgrade pathways, what happens when you're upgrading from version 1 to version 7 of your database. And so there's an element of risk there. Alternative to using the database is to use some sort of flat file storage. So this could be writing JSON or XML to disk, caching your network responses that way, or caching your user interactions or models, and then writing them to the SD card. And it allows you to iterate quickly because you don't have to think about your database schema and how you're going to model your database and how your data is going to change and setting yourself up for future success. But that's also an issue because you have limited upgrade pathways. So when you're upgrading from one version to another, you're not able to persist the data if your models change. You just have to delete the files and then recreate them. There's also a possibility of writing a corrupted model. That's a long-running operation to write JSON files to disk. And so if the user swipes your app away while they're writing this, they're going to get a partially written file. And when you come back, you're going to have to deal with the ramifications of that. And right. So the second strategy I recommend is to sense a fresh application start and then navigate the user back to a safe place. So the way I've typically done this is by leveraging the same fact that we know that all of our in-memory models that are in the application class or static singletons are torn down and then recreated fresh in a clean state when the process is recreated. So here, if we use them like a blackboard and we write them down, we know that we've gone through our proper initialization for the application. If we end up 5 activities deep in the task stack and the necessary requirements aren't there, then we can know to go ahead and get out and navigate back through our landing page or our welcome experience or our main activity. I think that typically when the user comes into our app, this is the experience they might expect. So sometimes when you're developing and you're causing process death and then you're immediately coming back in, this may not be what you would expect as a developer. But our users are backgrounding our app and then they're leaving it for a day. They're coming back 2 hours later. And so when they touch the launcher icon, I don't think they necessarily expect that they're going to be landing back on a checkout page. They're expecting they're going to enter the app. So if they're entering whatever your welcome experience is or landing on your home page, that's kind of expected behavior. All right. The final one that I suggest is a hybrid approach of recovering from disk and also navigating to a safe space. So in this one, what we do is we're going to save our session-based data to disk. We're going to navigate back to a safe place and try and load enough to bring the user back to where they were. And then if anything goes wrong loading that, for instance, if the JSON files that we wrote to disk ended up being corrupted, they see the normal user experience. If everything goes good, they land back where they were. It also tends to be much less work because you don't have to have full database support to do this. You could, if you're leveraging kind of the 1B approach of storing just enough data in your bundles and intents to reload, then you have minimal overhead for what you're actually writing to disk. Right. The fourth approach is anything else that makes sense for your app and your user base. So I've successfully used the first 3 options in different apps, but maybe you have a different use case, different scenarios, different things that make sense for your app. By all means, go ahead and use those. It's all about presenting our users with the best experience, not necessarily fitting to some paradigm that worked for somebody else. Thank you guys for coming. I appreciate feedback, either on the app, or you could tweet at me at mathematicalfunk, or just come up to me afterwards. And open floor for questions and discussion.
So most of the methods you discussed for killing an app, killing your process, involve doing something on the device itself. Do you have any recommendations for using maybe ADB or some other tools for achieving the same result?
Yeah, so when I was first looking into this, before I created that helper app for myself, I was scouring the internet, and some people recommended some things within Android Studio or some things with ADB, and I couldn't get any of them to put me in this state where the application was dead and it was bringing me back to the most recent activity that I was on, that I was seeing my users experience via crash reporting. So that's why I kind of set out to find the alternatives and understand what was going on. So there's some people that are suggesting like a ADB shell kill-am or clicking a stop button with certain things in Android Studio. And maybe it was my device, maybe it was my version of Android Studio or my version of ADB, I don't know, but it didn't work as I was expecting it to. So I'm not suggesting it because it hasn't worked for me personally.
Awesome, thanks.
The most recent Android project that I worked on had a Dagger model. Oh, sorry. It was using Dagger, and it had this module where every method was annotated singleton. And I'm wondering if that would be a situation where it'd be appropriate to say to that developer, hey, it looks like you're producing a ton of singletons. This could pose a problem if the application gets killed. Is that the right way to look at it, or are you thinking of a different kind of singleton case?
I'm going to quote Hwin from this morning and say it depends. Because the singleton pattern is a great pattern. And it's useful in lots of cases. I think the danger is the combination of using the singleton pattern to store models that you're using to populate UI and expecting it to be pre-configured when you're landing somewhere deep within your task stack. So if you're using that, instead of writing to the database, a shopping cart, and you're expecting that on a checkout screen, then that's the issue. So singletons in and of themselves, or static factories, are not a bad thing.
This is a little bit of an inane question, maybe, but I'm curious where you got all your little zombie monster android drawings.
One of my coworkers, Angie Hackinson, she made them for me, and they're adorable.
They're pretty sweet.
So how do you initially detect that your app has a problem with zombie apps? Do you have like users reporting? Do you do like manual testing and then you just catch something?
So I actually saw this the first couple apps I worked on. One of them, I was relying on some of these bad patterns of setting up data on one screen as a singleton and expecting it on a later class. And I had user reports that they would get to this later activity and nothing would be populated, and they would send me screenshots. And we didn't understand what was happening. And then I did code reviews for some companies, and they were having the same issue. And I've seen Android books that suggest this is a pattern, and I see Stack Overflow posts that suggest this is a pattern. And so it wasn't until we actually solved the crash reports of how is this happening, because it wasn't a configuration change, it was something else going on. And so finally I found a way to reproduce it via the Samsung font style trick, because I thought I was causing a configuration change, but it was actually slightly different. And then investigating what was happening through logging on Android Studio is where I kind of learned it.